Okay, so we're going to look at some more examples on solving absolute value equations. And in these examples, the majority of the examples we're going to look at will have variables on both sides. Some of them will have absolute symbols on both sides. And then we're going to also continue looking at absolute value equations where we have quadratic expressions. Before you can solve a absolute value equation, you need to make sure you understand what the idea of absolute value means, or one idea of what that means. So for example, suppose I want to find the values of x for which the absolute value of x is equal to, let's say, 2. Okay? So I want to find out what values of x, such that when I take the absolute value of it, I'll get the value of 2. I'll get 2. So remember, the absolute value of a number measures the distance that number is from 0. So if I look at the number line, and if I put 0 right here, what I'm asking here is this: what number will be 2 units from 0? So you know that the number 2 is 2 units from 0, right? So x equal 2. You also know that the number -2 is also 2 units from 0, correct? So x is equal to -2 as well. So when solving this equation, this absolute value equation, there are two solutions. There are two numbers whose distance is 2 units from 0, 2 and -2. Now, when solving these equations, it's a good idea to notice how we went from here to here very quickly. So notice that the variable expression on the left side of the equation here is what's inside of the absolute value bars. And the numbers on the right side are opposites of each other, right? See that? 2, -2. And the numbers you see here come from this number on the right side of the original absolute value equation. So in general, if you have the absolute value of some variable expression is equal to a number, you can rewrite this as two equations without the absolute value expression. So you would say what's inside the absolute value bars, u is equal to a, and then also u is equal to the opposite of a. Okay? And so that is what we're going to use when solving the following equations. All right, so let's go ahead and get started this. So let's look at number 1. Okay, so number 1, we have this absolute value equation. Notice that the variable expression that's inside the absolute value bars is a linear expression. So we have this absolute value equation. Now, when solving the absolute value equation using what we just talked about, it is very important before you write it as two separate equations to make sure that the absolute value expression is by itself. Okay, so in other words, if I rewrite this over, what I'm indicating here is this: I need to make sure that this absolute value expression right here is by itself. So notice that I'm adding to this absolute value expression the number 3. So I'm going to go ahead and subtract 3 from both sides, just like this. I'm going to just go ahead and do it vertically where I'm aligning my like terms. And so combining like terms, 3 minus 3 is 0, and 0 plus this absolute value expression here is that absolute value expression. So I get 4x minus 1. The absolute value of 4x minus 1 equals 7. Now notice I now have the absolute value expression by itself on the left-hand side. And it doesn't matter, you can have it on the left or the right, as long as the absolute value expression is by itself. Once I get to that point, remember what we discussed. So we're going to take that we're going to take that variable expression that's within the absolute value bars, and then we're going to write two separate equations using it. And the numbers you have on the other side, and I say the numbers, in a little while you're going to see that it doesn't have to be numbers, it could be variable expressions as well, but you're going to take the opposite of each other. So A, and then the opposite of A. Okay, so you'll see what I mean in a little while. But in this case, we have a 7 here. Now, just to remind you, notice that, remember, you can only, when we take the absolute value of some expression here, okay, when you take the absolute value of some expression, that number you get will either be positive or 0. It should never be negative. Remember, because absolute value measures the distance that a number is from 0, and that distance is always positive. So when I solve this, those two, and I'm going to get two solutions in this example, but when I solve this, it's not necessary to go back and check, because when I got to this point, that number here is positive or 0. In this case, it's positive. It's a positive 7. All right, so then I'm going to go ahead and solve. So I'm going to rewrite this. Remember, the variable expression on the inside, you write again, 4x minus 1 equal this positive 7, or 4x minus 1 equals a, and you take the opposite of that, negative 7. And those are your two equations. So notice I went from an absolute value equation to two linear equations. And let's just go ahead and solve. So I'm going to add 1 to both sides. So when I add 1 to both sides, I get 4x equal 8. Divide both sides by 4. One of my solutions is 8 divided by 4, which is 2. The other one, I'm going to add 1 to both sides. So I get 4x equal negative 7 plus 1 is negative 6. Divide both sides by 4. 4 divided by 4 is 1. 1 times x is x. And then when I reduce negative 6/4, I get a negative 3/2. Okay, so those should be your two solutions. So if you went back and you substituted both of those in the original, the left-hand side will equal 10 in both cases. Okay? All right, so that's number 1. So that was a very simple example to start off with. So let's get to the next example. Okay, so in this example, notice I have an absolute value equation, but this is different than the previous one, right? So if you look at the previous one, when I got to this point here, the absolute value expression was on one side, and a number was on the other side. A constant was on the other side. But notice here, I have the absolute value expression on one side, but on the other side, I have a variable expression. So I have variables on both sides. But the idea is the same, so don't let that throw you off. You're still going to use this idea here. Okay, so remember, whatever you see here, you're going to write, and then on this side, you're going to take the opposite of what you see here. So here's how we're going to do this. So the absolute value expression is by itself, so I'm going to go ahead and rewrite this as two separate equations. And so I get, remember, you rewrite what's inside the absolute value expression here, the absolute value bar. So it'll be x minus 1 equal the other side, just like this, okay? Or x minus 1, okay, now remember what we did, so listen carefully. I'm going to go back to that first example. So we said 4x minus 1 equals 7, or 4x minus 1 equals the opposite, right? Okay, so listen to the words. So x minus 1 equals 2x plus 7, or x minus 1 equals the opposite of 2x plus 7. So here's how you're going to write this, the opposite of 2x plus 7. So remember in the previous course, that's how you read this, the opposite of 2x plus 7. And then let's go ahead and solve each of those linear equations now. So I went from an absolute value equation to two linear equations. So let's go ahead and solve each one. So to solve this one, I'm going to go ahead and subtract x from both sides. I'm going to bring the variables to the right-hand side. So I'm going to subtract x from both sides, combining like terms. X minus x is 0. 0 and a negative 1 is a negative 1, equal 2x minus x is x, and then plus 7, right? And then to solve for x, to get x by 7, right now I'm adding 7, so the opposite, I'm going to go ahead and subtract 7. And so when I combine like terms, 7 and negative 7 is 0, so I get x equal negative 8. All right, so that's what I have so far. Now don't be a little bit careful. Just go ahead and write what you see here. On this side, I'm going to go ahead and distribute. And so I get x minus 1 equals the opposite of 2x is a negative 2x. The opposite of a positive 7 rather, is a negative 7. All right, now on this case, I'm going to go ahead and bring the variables to the left-hand side. It does not matter, right? So remember how to, when solving linear equations, You can bring the variables to the left or to the right. Does not matter. I'm going to go ahead and bring it to the right so that way I can get the coefficient of x to be positive. So I'm going to add 3x to both sides, combining like, 2x, excuse me, 2x to both sides. Combining like terms, x and 2x is 3x, minus 1 equal. Negative 2x and 2x is 0. 0 and negative 7 is a negative 7. Adding 1 to both sides, I get 3x equal a negative 7 plus 1 is a negative 6. Divide both sides by 3. I get x to be negative 2. Okay? All right, now remember what we said in the previous example. When we got those two solutions, I indicated this. I indicated it is not necessary to go back and check the original equation, because when I got to this point right here, now as long as I did this correct, when I got to this point, I have a positive number on this side. So remember, the absolute value of an expression has to always be positive or 0. It can never be negative. But when I got to this point here, when I got to number 2, I have that absolute value expression by itself, but on this side I have a variable expression, right? So we have to be a little bit careful here, because this expression, depending on what x is, that expression could be positive, that expression could be 0, that expression could be negative. All right? But remember, when I take the absolute value of some number, that value here better be positive or 0. It could never be negative. So I do have to check. You must check. You must check. Okay? Because one of these or both of these could make this right here, that variable expression, negative. So you must check. Okay? So when you have variables on both sides, just remember, and you don't see an absolute value here, just remember that this right here could be negative, so you do have to check your potential solutions, your proposed solutions. Okay? So let's go ahead and check the first one. So let's go ahead and check x equal negative 8. So go back to the original. So here's the original. So we'll go ahead and rewrite it right here. The absolute value of x minus 1 equals 2x plus 7. So where we see the variable x, I'm going to substitute negative 8. So I get the absolute value of negative 8 minus 1. And I want to see if that's going to equal 2 times negative 8 plus 7. Well, negative 8 minus 1 is a negative 9, so I have the absolute value of negative 9, right? And right away I know the absolute value of a negative 9 is a positive 9. Okay? So the left side is 9. On this side, I have 2 times negative 8, which is a negative 16, and then I'm adding 7. And a negative 16 plus 7, that is a negative 9. And notice a 9 does not equal negative 9. So x equal negative 8 is not a solution. X equal negative 8 is not a solution. Okay, so depending on your textbook or the class you're in, sometimes we say that x equal negative 8. See how it's not a solution? Sometimes we'll say x equal negative 8 is an extraneous solution. So remember, extraneous solutions are values that we get when solving equations that aren't really solutions to the original equation. So x equal negative 8 is not a solution to this original equation. But remember, it is a solution to this equation here. So that's still true. X equal negative 8 is a solution here, but it's not a solution to the original. Okay, so we say that x equal negative 8 is an extraneous solution. So it's kind of like a false solution. Okay, so when you're asked to list the solutions, don't put x equal negative 8, because you're asked to find the solution to this original equation. All right, so let's go ahead and check the next one. So let's check x equal negative 2. So check x equal negative 2. And you go back to the original. Remember the original. You must always go back to the original, because that's what you're checking the solutions for. Okay, so in the place of x, for x, I'm going to substitute negative 2. So I get the absolute value of negative 2 minus 1 equal, I want to see if that's going to equal 2 times negative 2 plus 7. A negative 2 and a negative 1 is a negative 3. So I have the absolute value of negative 3, which we all know is a positive 3. So on my left side is 3. And then on my right side, 2 times a negative 2 is a negative 4, and a negative 4 plus 7 is a positive 3. So notice those two are equal. So x equal negative 2 is a solution to the original equation. And so therefore your solutions, there's only one. There's only one solution, and it is x equal negative 2. Okay? So just a reminder, when you're solving an absolute value equation and you have variables on both sides, you must check, because this variable expression that's on the right-hand side, that variable expression on the right-hand side, depending on what value you substitute into x, could be positive, could be negative, or could be 0. Okay, remember, the absolute value of an expression is always going to be positive or 0. It is never going to be negative. Okay, so that was number 2. Now, let's go back and look at this one for number 3. So the question becomes this. Well, what if, so you see I'm looking at number 2 again, but what if I want to solve this absolute value equation? So it's almost like the previous one, right? Except on number 3, both expressions on both sides, I'm taking the absolute value of it. All right, so you may say, well, how do you solve an absolute value equation where there are variables on both sides? Well, that's a good question, and you're going to do it the same way you did all the others. You're going to do it this way. So you're going to rewrite it just like this. And you're going to say, I'm going to take this variable expression, I'm going to set it equal to this variable expression, just like you did before. X minus 1 equals 2x plus 7. Or you could say this, I'm going to take this variable expression, x minus 1, and I'm going to set it equal to the opposite of this variable expression, 2x plus 7. And then you may say this, you may say, well, isn't this right here the same as what we did here? And the answer is yes. You see that? So when solving an absolute value equation that has the absolute value bars on both sides or on one side, the process is the same. So notice when I solve this linear equation, remember when I solved it, I'm not going to go ahead and do it again because we already did it before. I got x to be negative 8, right? So notice the process. You got x to equal negative 8. And over here, when I solved this equation, I ended up with x equal negative 2. And then when we got to this point here, remember for the number 2, when I got to this point, since I had a variable expression on the right-hand side, I had to check. And we saw that one of those was not a solution, but the other one was, right? Okay, so you may say, well, what's the difference here? Well, the difference is both variable expressions are within absolute value bars. So when we talked about right here that this variable expression in number 2 could be positive, could be negative, could be 0, right? And when I look at this right-hand side here, that variable expression that we saw could be positive, and the absolute value of a positive is still a positive, correct? Or it could be negative, and the absolute value of a negative is a positive, right? Or it could be 0, and the absolute value is 0, 0. But notice that in number 3, this side is never going to be negative. And this side is never going to be negative either, right? Because I'm taking the absolute value. So the point being is this. As long as you're doing this correctly, since I have absolute value bars on both sides, there's no need to check the solutions because you have absolute value bars on both sides. All right, but many students do. If they see absolute value expressions on both sides, variable expressions on both sides, they automatically check. All right, but let's go ahead and check and see why both of them will work this time. All right, so let's check this one. So let's check x equal -8. And I'll go back to the original, which is the absolute value of x minus 1 equal the absolute value of 2x plus 7, right? And so when I substitute -8, I get the absolute value of -8 minus 1. And I want to see if that's going to equal the absolute value of 2 times -8 plus 7, right? -8 and a -1 is a -9. So I get the absolute value of -9, which I know is equal to a positive 9. Over here, 2 times -8 is a -16. But remember, that's inside the absolute value bars. So -16 plus 7. -16 plus 7 is a -9. So I'm taking the absolute value of -9, which we know is positive 9. And notice this time x equal -8 is a solution. Whereas in the previous one it was not. But I'm hoping you realize it was not because there was no absolute value bars on this side of the equation. Do the same thing for the other one. When you check x equal -8, x equal -2, you get the same thing. So watch what happens. So you get -2, the absolute value of -2. Remember, wherever you see the variable x, substituting -2. So I get -2 minus 1. And you will see that's going to equal the absolute value of 2 times -2 plus 7. -2 and a -1 is a -3. So you get the absolute value of -3. And you know that that's equal to a positive 3. Over here, the absolute value of 2 times -2 is a -4. -4 plus 7. -4 plus 7 is 3. And the absolute value of 3 is also 3. So that works as well. So these two proposed solutions are actually solutions. So the solutions are x equal -8 and x equal -2. Okay? All right. So just be aware. So there are some situations where you could have variable expressions on both sides where only one side has absolute value bars, or both sides could have absolute value bars. Okay? So let's look at number 4. So number 4, let's suppose we had this equation. Okay, so we had the absolute value of 4x minus 2 divided by 5 equal the absolute value of 6x plus 3 divided by 2. So notice there are absolute value bars on both sides, right? So whatever you substitute for the value of x, this number right here will either be positive or 0. It will never be negative. Same thing here. Okay, so notice that the absolute value expressions are all by themselves. So let's go ahead and rewrite this without the absolute value bars. So we're going to split it apart. You're going to write it as two separate equations. And so remember that when you rewrite it, you're going to take the variable expression that's in the first one. You're going to set it equal to the variable expression that's in the second, right? So you're going to get 4x minus 2 divided by 5 equals 6x plus 3 divided by 2. And on the other side, for the other one, you're going to do this. You're going to take the variable expression that's on the left side, 4x minus 2 divided by 5 equal the opposite. Remember, you must do the opposite. So the opposite of this one. So the opposite of 6x plus 3 divided by 2. Okay, just like that. Okay, so let's go ahead and solve the first one. So notice that the first one you have a proportion. You have a ratio equal to a ratio. So the easiest way to do that is just to cross multiply. So let's go ahead and do that. So I'm going to get 2. So you're just going to cross multiply. So I'm going to get, let me go ahead and do this one. So it'll be 5 times 6x plus 3 is equal to 2 times 4x minus 2. And then distributing, using the distributive property, I get 5 times 6x is 30x, 5 times 3 is 15, equal, and then 2 times 4x is 8x, and then 2 times -2 is a -4. So I went from this absolute value equation to two linear equations. Okay, so let's go ahead and subtract 8x from both sides. So 30x minus 8x is 22x plus 15 equal 8x minus 8x is 0. 0 negative 4 is a negative 4. Subtracting 15 from both sides, I get 22x equal a negative 4 and a negative 15 is a negative 19. And then dividing both sides by 22, I get x equal negative 19 divided by 22. Okay? All right, now, okay, so let's go ahead and solve the second equation. Now remember, when we did that one, we said the opposite of this, so be careful. So I'm going to go ahead and take the opposite of this rational expression. Now when taking the opposite of the rational expression, we're just going to take the opposite of the terms that's in the numerator. So you've got to be careful. Don't take the opposite of both numerator and denominator, only the opposite of the terms that's in the numerator. So when I do that, I'm going to get 4x minus 2 divided by 5 equal, and the opposite of 6x is a negative 6x, and the opposite of a positive 3 is a negative 3 divided by 2. Okay? Still, you may see the denominator is 2, the denominator is 2. So it's only the opposite of the terms that's in the numerator that I'm going to do. Now, you could keep the numerator the same and just take the opposite of the denominator, and that's fine as well, as long as you take the opposite of either the numerator or the opposite of the denominator, but not both. Okay? All right, so then cross multiplying, because we have this proportion again. So when I cross multiply, I get 5 times negative 6x minus 3 equal, and then 2 times 4x minus 2. Distributive property, I get 5 times negative 6x is a negative 30x. 5 times negative 3 is a negative 15 equal 2 times 4x is 8x, and then 2 times negative 2 is a negative 4. Okay? I'm going to go ahead and bring the variables. Notice I went from an absolute value equation to, in this case, 2 linear equations, right? So I'm going to go ahead and bring the variables to the right-hand side, so that way the coefficient of x will be positive. So I'm going to add 30x to both sides, just like this. 30x and a negative 30x is 0. 0 and negative 15 is a negative 15 equal 8x and 30x is 38x minus 4. Adding 4 to both sides. Negative 15 and 4 is a negative 11 equal 38x. To get x by itself, I'm going to divide both sides by 38. And so my other solution is negative 11 divided by 38. Okay, now remember, so the next thing you need to ask yourself is, do I have to check these or not? Because sometimes we did and sometimes we did not, right? We'll go back to the original. So notice that I have variable expressions on both sides, right? But they're both contained within absolute value bars. So as long as you are sure that all this work is correct, then these will be solutions to the original, because of the fact that both sides, both variable expressions, are within absolute value bars. None of those will ever be negative. All right? So, and I'm certain that these are correct. I don't think I did make an error anywhere. So those are your solutions. Okay? So let's go ahead and start looking at a couple of problems where we have quadratic expressions involved. So let's look at number 5. Okay, so here's number 5. So notice I have an absolute value equation, and within the absolute value bars, I have a quadratic expression. Okay? Now, be careful. Sometimes students seem to think that this equation that you see here is quadratic. That's not a quadratic equation. It is an absolute value equation that contains a quadratic expression. All right. So remember, these are absolute value equations. The graph of an absolute value equation is in this case is not the same as a quadratic equation, quadratic function. So be careful. Make sure you know the terminology. So this is an absolute value equation that contains a quadratic expression. Now, when I notice the absolute value bars are by themselves, is on one side by itself, right? So now I'm going to rewrite this. But when I rewrite this, you rewrite it without the absolute value bars. So remember our process. So you're going to take the variable expression within the bars, absolute value bars, and you're going to set it equal to the other side. And then you're going to take the variable expression and you're going to set it equal to the opposite of the other side. Okay? So here we go. So the variable expression that's within the absolute value bars is x squared minus 5x. That's going to equal 6. Or x squared minus 5x equals the opposite of 6. Now, so I went from an absolute value equation. Now I have two quadratic equations. See, these are quadratic equations now because there's no absolute value bars anymore. Okay? Okay, so let's solve each of those quadratic equations. I think they're both factorable, but regardless, whether you use the quadratic formula or you try and factor, you need 0 on the other side. So let's go ahead and subtract 6 from both sides. So I get x squared minus 5x minus 6 equals 0. Factoring, let's say I'm going to get x minus 6 times x plus 1 equals 0. And then setting each factor equal to 0, just like this, so I went from a absolute value equation to a quadratic equation, and then to solve this quadratic equation, I now have two linear equations. So I get x equals 6, x equals negative 1. Okay? And then let's go ahead and do that one. So I'm going to add 6 to both sides this time. So I get x squared minus 5x plus 6 equals 0. And this one's factorable as well. So I get x minus 3 times x minus 2. And then setting each factor equals 0, x minus 2 equals 0, x minus 2 equals 0. And then solving these linear equations, I get x to be 3, x to be 2. And so notice I have 1, 2, 3, 4. 4 proposed solutions. Now your questions has to be now, do I need to check those? Will any of those be extraneous? And the answer is no. Because on the other side, when you got the absolute value by itself, when the absolute value bars are by themselves, that other side's a constant, and that constant is positive. So if you did the work correct, each of those will be solutions. Okay? And you can check each one if you want to. So if you want to check one of them, you can, and you'll see. For example, let's go ahead and do 6 right here. So let's just check 6. Just to show you. So x equals 6, you go back to the original, right? So x squared minus 5x, absolute value, and we'll see that's equal to 6. So we see the variable x, and you substitute 6. And so you get 6 squared minus 5 times 6, right? 6 squared is 36. Don't forget the absolute value bars. 36 minus, and then 5 times 6 is 30. 36 minus 30 is 6, and the absolute value of 6 is 6, which is what you had there. Okay? So, and you can do the same thing with negative 1. Some students have trouble with negative 1, so if you got to be a little bit careful. Make sure, I'm going to go ahead and rewrite this. Make sure when you replace the variable x with negative 1, you put that in parentheses. Okay, so I have, you see the variable x is, I'm going to substitute negative 1. So I get negative 1 squared minus 5 times negative 1. Negative 1 times negative 1 is positive 1. A negative 1 times a negative 5 is a positive 5. Don't forget the absolute value bars. 5 plus 1 is 6, and the absolute value of 6 is 6, which is what I had here. So and you can go on for the rest, and you'll see that all of them will work. But the point is this. Since that number here was a constant, okay, you had the absolute value bars by itself, that number was a constant, and that constant is a positive 6. As long as you did all this work correct, each of those will be solutions. Now, some students will go ahead and check all of them because they could have made an error, right? So they know that whatever you get here better be a solution. So there are students that will go ahead and actually check these, even though they know that there's no need to do it because of that positive 6 there. But you could have easily made a mistake here. So, for example, going from here to here, I could have made a mistake and said x equal 1. and x equal 1, if I checked, it would not have worked. So I knew that I would have had an error somewhere. So it's sometimes a good idea, even though you know that since that's a positive 6, all these will be solutions. Sometimes a good idea to verify, because you could have made a mistake. Okay? All right, so that's number 5. Let's go ahead and look at one more, and let's look at this one. All right, so this will be number 6. Okay, so here is number 6. So notice I have an absolute value equation. I have variables on both sides, right? And notice that on one side I have a quadratic expression, and within this absolute value bars I have a linear expression. Don't let that throw you off. You know the process. The process in every one we've done has always been, once you get the absolute value bars by itself, that absolute value expression by itself, you rewrite it as 2 separate equations. The same thing applies here. So it's not difficult. It's still the same process. You're going to continue using this process right here. Okay? So let's go ahead and do that. So I have this absolute value equation. I'm going to go ahead and rewrite this since I already have the absolute value expression by itself. So remember, when you rewrite it, you're going to take that expression that is within the absolute value bars, and you're going to set it equal to the other side, just like that. Or you're going to take the absolute value, the variable expression that's within the absolute value bars, and you're going to set it equal to the opposite of the other side, right? So remember, A, opposite of A. X squared minus 4x minus 3, the opposite of x squared minus 4x minus 3. Okay? All right, let's go ahead. Now notice I went from an absolute value equation to 2 quadratic equations. These are now quadratic equations. Okay. So let's go ahead and solve the first one. So remember, I've got to get 0 on one side. So since x squared already has a coefficient of 1 over here, it's positive. The coefficient is positive. I'm going to bring the terms to the right hand side. So I'm going to go ahead and subtract x from both sides. So x minus x is 0. 0 and 3 is 3. So I get 3 equal x squared. A negative 4x and a negative x is negative 5x minus 3. Subtracting 3 from both sides, 3 minus 3 is 0. I get 0 equal x squared minus 5x minus 6. Okay? And I'm going to go ahead and transpose both sides. I'm going to get x squared minus 5x minus 6 equals 0. Okay, now this one's factorable, so let's go ahead and factor. And when I do that, I'm going to get x minus 6, x plus 1 equals 0. Setting each factor to 0, using a 0 factor property, I get x to be positive 6 and x to be a negative 1. All right? Now let's look at the other one. So in the other equation, I'm going to go ahead and distribute the negative here. So get x plus 3 equal the opposite of x squared is a negative x squared, the opposite of negative 4x is a positive 4x, and the opposite of a negative 3 is a positive 3. All right, now, see that x squared has a negative coefficient? I'm going to go ahead and bring all these terms to the left-hand side. So I'm going to add x squared to both sides, just like this, and then combining like terms, I'm going to get x squared plus 3, x squared plus x plus 3 equal, and on this side, the x terms cancel out. You get 0, and you get 4x plus 3. And then subtracting 4x from both sides, I get x squared. X and a negative 4x is a negative 3x plus 3 equal 4x minus 4x is 0. 0 plus 3 is 3. And then finally, subtracting 3 from both sides, I get x squared minus 3x. Now be careful, 3 and a negative 3 is 0, right? So all this right here, when you combine like terms, just ends up with these two terms here. And that's equal to 0. All right? Now, when solving this equation, notice you have to remember, you have to look for a GCF as well. So the GCF here is x. I'm going to factor out an x, and I get x times x minus 3 equals 0. And then setting each of these factors equal to 0, I get x to be 0, x minus 3 equals 0, so x is 3. So notice I have 1, 2, 3, 4 proposed solutions. Now the question you got to ask yourself is, do I need to check them? So remember in number 5, when you had these 4 proposed solutions, we saw that it was not necessary, right? It was not necessary because this side here was always positive. And on this side, though, we have a variable expression. So this could be, depending on what x is, this side could be, and there's no absolute value bars, okay? So there's only one set of absolute value bars. So yes, you do have to check, because this side could be positive, this side could be 0, and this side could be negative. And it's the negative that you don't want, because the absolute value on this side is going to be positive or 0. So this value on this side is going to be positive or 0. And this could be positive, 0, or negative, and it's the negative that you don't want. So we do have to check. We have to check all of these solutions. Okay, so you must check. You must check. Since on this side you have a variable expression without absolute value bars. So let's go ahead and check the first one, x equals 6. So it's a little bit of work we have to do, but you got to do it. So here's the original equation. You must always go back to the original. So wherever we see the variable x, I'm going to substitute 6. So I get the absolute value of 6 plus 3, right? So right away I know that this will be the absolute value of 9, which is 9. So the left side is going to be 9. So hopefully the right side is 9 as well. Let's see what happens. So I get 6 squared minus 4 times 6 minus 3. 6 squared is 36. Minus 4 times 6 is 24 minus 3. 36 minus 24 is 12. 12 minus 3 is 9, and that is equal. So x equals 6 is going to be a solution. Let's check negative 1. X equal negative 1. So go back to the original. So I'm writing the original equation, just like this. And where we see the variable x, I'm going to substitute negative 1. So I get the absolute value of negative 1 plus 3. Negative 1 plus 3 is 2. So this becomes absolute value of 2, and the absolute value of 2 is 2. So the left-hand side is going to be 2. So hopefully the right-hand side will be 2 as well. So I get negative 1 in parentheses. Remember, if you're using a negative value of x, make sure you put that in parentheses. Be careful. So negative 1 squared minus 4 times negative 1 minus 3. Negative 1 squared is 1. A negative 4 and then times a negative 1 is a positive 4 minus 3. 1 plus 4 is 5. 5 minus 3 is 2. And those are equal. So x equal negative 1 is a solution. Okay, remember you got to check all of them. So we have 2 more to check. So let's go ahead and check x equal 0. Let's check x equals 0. So go back to the original, and we'll go ahead and write the original here. The absolute value of x plus 3 equal x squared minus 4x minus 3. Okay, so wherever you see the variable x, I'm going to substitute 0. So I get the absolute value of 0 plus 3. 0 plus 3 is 3, so that's absolute value of 3, which we know is a positive 3. So the left side is 3. Let's check to see what happens on the right side. So I get 0 squared minus 4 times 0 minus 3. 0 squared 0 minus, and then 4 times 0 is 0 as well, minus 3. 0 minus 0 is 0. 0 minus 3 is a negative 3. Notice those are not equal. So x equals 0. X equals 0 is not a solution. It's not a solution. So remember, you can say x equals 0 is extraneous. Okay, so it's not a solution. All right. So far we only have 2 solutions. So this one right here is extraneous. That's not a solution. Now let's check x equals 3. So x equals 3. Check x equals 3. And the original equation was this: absolute value of x plus 3 equal x squared minus 4x minus 3. So wherever we see the variable x, I'm going to substitute 3. So I get the absolute value of 3 plus 3. 3 plus 3 is 6, and the absolute value of 6 is 6. Go over here. I have 3 squared minus 4 times 3 minus 3. 3 squared is 9. 4 times 3 is a negative 12. and then minus 3. 9 minus 12 is a negative 3. A negative 3 to negative 3 is a negative 6, and those are not equal. So x equal 3 is not a solution. Not a solution, right? You could also say x equal 3 is extraneous. All right, so on that first page here, this right here is extraneous. So in terms of your solutions, so if you were told to write down the answers, so you'd say the solutions are, and there's only two, right? There's only two, 6 and negative 1. X equals 6 and x equal negative 1. Okay? All right. So hopefully those 6 examples should help you with understanding how to solve absolute value equations where we have variables on both sides. We have absolute value symbols on both sides, and we also have problems where we have quadratic expressions. All right, so that is the end of this lesson.